Hello folks, and happy Tuesday. Hope you're having a great day so far, and hopefully this will make it even better. We're going to continue on this journey of factoring trinomials. Okay, yesterday we looked at a couple different items. We looked at factoring with a greatest common factor. Okay, pulling out a term that's the same in every item, every term, pulling out a common factor. Then, after that, we looked at some binomials that were of a certain form. And sometimes you hear it called dots, D-O-T-S, difference of the squares. And when we recognized that, we were able to factor into the square root a plus the square root b, and the square root of a squared, which is a minus b. Those were the two items we studied yesterday. Today we are going to move into trinomials, three terms. Okay, one form of is going to be where our trinomial has a leading coefficient that's equal to 1. In other words, it'll look like x squared plus bx plus the number c. The other type of problem that we're going to look at is when the leading coefficient is not 1. So you'll have a number multiplied by x squared plus a number times x plus a number at the end. So you're going to have to distinguish between those two types of problems today. All right, we are going to start out with our learning target. I can factor a trinomial with a leading coefficient of 1. So if you notice on all of these problems, on all three of these problems, the first term is 1x squared. The coefficient is 1. When we factor trinomials of this form, we are trying to break it up into two binomials. A number times x plus b, another number, and a number times x plus d, another number. Okay? We have to solve by finding these four numbers in order to factor. Okay? We're trying to locate those numbers. Well, the first two are going to be straightforward. Okay? The first two numbers, when multiplied, will equal the first value of the trinomial. So the only way to get that is x times x. The last two numbers in the binomials, when you multiply those, you have to get 12. Okay? However, they have to add up to that middle number, which in this case is -7. Okay? So we are looking to multiply to the last number and add up to -7 for the middle number. Well, we can multiply -4 and -3 together to get +12, and we can add -4 and -3 together to get -7. Okay? So those are my two terms, and that is my solution, x minus 4, x minus 3. Some people call this method trial and, say it, success. We wouldn't want to try until we err. remember, it's okay to chuckle a little bit and laugh a little bit while you do math. All right, problem number 2. Again, this is a trinomial, 3 terms, with our leading coefficient, which is really just a 1. Okay? We are trying to put this into the form of ax plus b times another binomial, cx plus d. Okay? Well, we know right away when the leading coefficient is 1, the first value in each binomial has to be x, because when we multiply them together, we get x squared. Now, we have 2 numbers here that have to multiply to 30. So one number times another has to be 30, and those same 2 numbers have to add up to 13x. Well, we got some different options, right? I could try 6 and 5, but those don't add up to 13. Okay. If you think some more, you might get to 3 and 10. 3 times 10 is 30. 3 plus 10 is 13. So I put 3 and 10 in there, and I have my solution. X plus 3, x plus 10. Okay. It's okay if the 2 groups are switched. That's okay also. All right. Let's take a look at the last example here. Okay. Now I'm going to make a change here. Math alarm, I'm going to make a change. This is going to be plus 48. Plus 48. Okay. Now again, as I look at this problem, the first number is 1. Leading coefficient is 1. So I know right away I'm trying to break it into 2 binomials. Okay. What times what is x squared? Well, I know that that's going to be always x times x when it's a leading coefficient of 1. My next goal is to finish out and figure out what numbers go there. Okay, what 2 numbers are going to fill in those spaces? Well, I have some clues here. 2 numbers that multiply to positive 48 and add to negative 16. Okay. Well, if we think about 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12. Well, there it is. Negative 4 plus negative 12 equals negative 16, and negative 4 times negative 12 is positive 48. So I now know that my binomials are negative x minus 4, x minus 12. So my final answer can be written with either group first, but you must have the signs correct. You can always check your answers with the distributive property. All right, folks, now we're going to change the trinomials a little bit. If you look at all 3 of these trinomials on this page, what you will notice is that the leading coefficient is no longer equal to 1. Okay, we're still going to factor this. We still are going to factor this. Our goal is still to factor it into 2 binomials, but it's going to take a little different approach because of that number in front. So what we're first going to do in this case is we are going to multiply the 2 times 30. And we are going to get 60. Okay, now that's going to become one of my new key numbers. I'm going to look for now, instead of two numbers that multiply to the 30, we are going to have two numbers that multiply to the 60. I got that from the 2 times 30. But they're still going to have to add up to that middle term of 17x. So we can start to list out some of the numbers. Oh, 3 and 20 is close. In order for that to equal 17, one of them would have to be negative. So that would not that would not multiply to a positive 60. Let's see. Oh, look at that. 5 and 12. There it is. 5 times 12 is 60. 5x plus 12x is 17x. Now, once I have those numbers, again, these problems are done differently because the leading coefficient is not 1. I need to rewrite the trinomial. Okay, I'm going to keep the 2x squared, but now I'm going to split that 17x up into the two numbers that I got, 5x and 12x. Those are the numbers that came from over here. Those are the numbers that added up to 17. And multiplied to 60. Now, this is now instead of being a trinomial, it now is a polynomial with 4 terms. But we are going to make the problem a lot easier. We are going to do grouping at this point. I'm going to take the first 2 terms and group them. And I'm going to take the second 2 terms and group them. I can focus just on this group and now pull out a greatest common factor. So this one, I can only pull an x out of both. And over here, however, I can pull out I can pull out a 6. Make sure it's the greatest common factor. Oh, and notice what happens. Powerful, powerful, powerful. We have another common factor. So I can take out the 2x plus 5 because it is common to both. And that's going to leave you with an x plus 6. And there you go. You've taken the original problem with a little work and turned it into 2 binomials. Okay, again, distributed property, you can check your work all the time. Check, check, check. Okay, we're going to rearrange the screen. All right, number 2. Again, important problem because that first number is not a 1. So I need to start by multiplying the 3 times the 15, get 45. That becomes my new key number. All right, I need 2 numbers that are going to multiply to 45 and add up to -4. Oh, little mistake there. They have to multiply to -45 and add up to -4. So not a lot of options here. 3 and -15 and -3 and +15 don't add up to -4. There we go. -9 and 5 add up to -4. And they multiply to -45. So again, remember what we do? We're going to rewrite the polynomial into 4 terms. Okay, I'm going to split the middle term into the 2 numbers that I got. Negative 9x and 5x. Now we can do some grouping. Make the smaller problems. So in here, I can pull out a 3x, and I have x minus 3 left. Plus, here, I can pull out a 5, and I have x minus 3 left. Look at that. I now have another greatest common factor. If I pull an x minus 3 out of both of those, all I have left is the answer. 3x plus 5. Outstanding. Outstanding. All right, here we go with a few more examples. Again, look at the trinomial. Okay, it does not have the 1x squared. It's got 16x squared plus 20x plus 6. So right away, I know what my goal is. I'm going to get 2 binomials for my answer. But I have to multiply the first and last number together and get 96. In order to factor this, I'm going to need 2 numbers that multiply to this 96, and they add up to 20. Add up to 20, multiply to 96. So you can start going with like your factors here. 96 and 1, 2 and 48, 3 and 32. And if you keep going, you're going to know that 8 times 12 is 96, positive both. So 8 plus 12 is 96. Or I'm sorry, 8 plus 12 is 20. So now I can take my original trinomial, and I'm going to break it up, and I'm going to take that 20 and make it 8x plus 12x plus 6. Now it's grouping. Pull out an 8. Pull out a positive 6. And now you know, whoops. Now you know that you're close to being right, because I have another greatest common factor that I can pull out, which is 2x plus 1, which leaves an 8x plus 6 left over. Again, you can always check your solutions. All right, folks. Hashtag the end.